home using a single wire. We have a small layout consisting of 3 rooms, a kitchen, and a corridor. We will perform UPS, inverter, wiring in these areas using a single wire. Our main power supply comes from the electric pole and connects to the energy meter. We will use a distribution board that includes a 63A 2-pole MCB and 6 single-pole MCBs. The single-pole MCBs are used to control the electrical power in each room. A neutral link is used for neutral distribution. In each room, kitchen, and corridor, we will install a switchboard. Additionally, we will have 1 ceiling fan and 2 lights in each room, 1 light in the kitchen, and 2 lights in the corridor. An inverter will also be used in the home, powered by a battery. We will provide 2 types of power supply to our switchboards, the main power supply and the inverter supply. Let's begin with the wiring. If you find this video helpful, please don't forget to like, subscribe, and share it with your friends. The phase wire from the supply company or pole is connected to the first terminal of our energy meter, while the neutral wire connects to the second terminal. The third terminal of the energy meter is the neutral output, which goes to the 2-pole MCB in our distribution board. The fourth terminal is the phase output of the energy meter, which also connects to the 2-pole MCB in the distribution board. The neutral wire from the 2-pole MCB output goes to the neutral link, while the second terminal of the 2-pole MCB, which is the phase wire, loops to the 5 single-pole MCBs, leaving the 6th one for the inverter supply. For the inverter, we will connect it to 2 types of power supply, the battery and the main power supply. We have 3 wires, red and black, and a power cable connected to our inverter. The red wire is the positive terminal of the inverter, which connects to the positive terminal of the battery. The black wire is the negative terminal of the inverter, which connects to the negative terminal of the battery. The remaining power cable is used to provide a supply to the inverter via a plug top. The brown wire connects to the right side of the plug top, while the blue or neutral wire connects to the left side. Through this wire, when the main supply is available, the inverter starts charging the battery. The phase wire of the inverter connects to the main supply wire through a relay installed inside the inverter. This ensures that when the supply is available, the main supply phase wire will be available in the inverter supply phase wire. To obtain supply from the inverter, we will use a 3-pin plug top. In this wiring, we will only use 1 wire, phase wire, and the neutral wire of the normal wiring will be used as the inverter neutral. We will connect 1 wire to the right side of the plug top and route it to the remaining MCB in the distribution board. The plug top we will connect to the socket of the inverter. The entire switchboard inverter supply will be controlled by this MCB. Now, let's move on to the switchboard connections. We will provide 2 types of power supply to all the switchboards, the main power supply and the inverter power supply. First, we need to decide which loads will be connected to the main power supply and which loads will be connected to the inverter power supply. We decide that each room will have a ceiling fan and 1 light connected to the inverter supply, and 1 light and socket will be connected to the main supply. In the corridor, one light and the socket will be controlled by the main power supply, while the other light will be connected to the inverter supply. In the kitchen, the socket will be controlled by the main power supply, and the light will be connected to the inverter supply. Let's start with room 1. We will connect a wire from the first MCB of the distribution board to the switchboard in room 1. This wire will be looped with the second switch on the switchboard. The first switch will be used to control a light, so we will connect a wire from the second terminal of the switch to the light. This allows us to switch the light on and off using this switch. The second switch will be used to control a socket, so we will connect a wire from this switch to the right terminal of the socket. Both the light and the socket in room 1 will be connected to the main power supply. Moving on to room 2, we will connect a wire from the second single-pole MCB to the switchboard in room 2. This wire will be looped with the second switch on the switchboard. The first switch will be used for controlling the light, so a phase wire from the second terminal of this switch will connect to the light. The socket in room 2 will also be controlled by this switch, so a wire from the second terminal of the switch will connect to the right terminal of the socket. Similarly, we will use single-pole MCB3 for the switchboard in room 3. A wire will go from this MCB to the switch and loop with the second switch on the switchboard. The first switch will control the light, so a wire from the second terminal of this switch will go to the light. The second switch will control the socket, so a wire from the second terminal of this switch will connect to the right terminal of the socket. We will use MCB4 for the kitchen switchboard. A phase wire from the second terminal of this MCB will go to the switch in the kitchen. We will control the socket from this switch, so a wire from the second terminal of this switch will connect to the right terminal of the socket. A wire from this MCB will go to the corridor switchboard and connect with the switch, looping with the second switch. This switch will be used to control the light, so a wire from the second terminal of this switch will go to the light. The second switch will control the socket, so a wire from the second terminal of this switch will connect to the right terminal of the socket. To give the main supply to the inverter, we will use a socket with a switch or a light plug. We will loop a phase wire from here and connect it to this switch, and a wire from the second terminal of the switch will connect to the right side of the socket. This light plug will be used for the UPS or inverter supply. With the completion of the phase wiring for the main power supply, we will now proceed to the inverter supply phase wiring for all the switchboards. A wire from the MCB designated for the inverter supply will connect to the switch in room 1 and loop with the second switch. The first switch will be used for the light, so a wire from the second terminal of this switch will connect to the light. A wire from the second switch will connect to the ceiling fan. Both the fan and the light will have the inverter supply. We will use a yellow-colored wire for the inverter supply in this wiring. A wire will be connected to the inverter supply wire and connected to a switch on the kitchen switchboard. This switch will control the light, so a phase wire from the second terminal of this switch will go to the light. Now, moving to room 2, a wire will loop from the inverter supply line and connect to the switch. This switch will control the ceiling fan, so a phase wire from the second terminal of this switch will connect to the fan. We will also loop a wire from this line to another switch. This switch will be used to control the light, so a phase wire from this switch will connect to the light. In room 3, a wire from the inverter supply line will loop to the switch and loop with the second switch. The first switch will be used for the light, so a phase wire from the second terminal of this switch will go to the light. The second switch will be used for the ceiling fan, so a wire from the second terminal of this switch will connect to the fan. In the corridor, we will give the inverter supply using a wire from the inverter supply line connected to the switch. In the corridor, we will control only one light with the inverter supply, so the wire from the second terminal of this switch will connect to this light. The inverter supply phase wiring is now completed. Please note that you can use separate MCBs for every inverter supply. For this purpose, you will need to install additional MCBs in the distribution board and loop them with the respective wires. Now, we will proceed with the neutral wiring for all the switchboards, fans, and lights. First, the neutral wire from the neutral link will go to the switchboard in room 1 and connect with the left side terminal of the socket. A neutral wire will loop from here and connect to the light. Additionally, the neutral wire will connect to the fan and the second light. Similarly, a neutral wire from the neutral link of the distribution board will go to the switchboard in room 2 and connect with the left side terminal of the socket. The same neutral wire will go from here to the light, as well as connect with the fan and the second light. Similarly, a neutral wire from the neutral link of the distribution board will go to the switchboard in room 3 and connect with the left side terminal of the socket. The same neutral wire will go from here to the light, as well as connect with the fan and the second light. A neutral wire from the neutral link of the distribution board will go to the kitchen switchboard and connect with the left side terminal of the socket. From here, the neutral wire will connect to the light. From this neutral wire, we will take a line and connect it to the left terminal of the corridor switchboard. Both lights in the corridor will be connected to the neutral wire. From this neutral wire, we will also take a loop and connect it to the left side terminal of the socket used for the inverter supply. With the completion of the phase and neutral wiring, we will now connect the earthing wire. The earthing wire will come from the earthing rod to the earthing link in the distribution board, and from the earthing link, it will distribute to all the switchboards and connect to the socket earth terminals. Please note that if you encounter any issues with your inverter and it fails to function, simply connect this plug to this socket. This will initiate the power supply to all the switchboard loads that are connected to the inverter. If you have any doubts or suggestions, please write them in the comment section.